So I need one more word, and it's interval of validity. And the kick here is that sometimes you're going to have a differential equation that you can write down a solution to, and the solution might only be valid for a certain amount of time.
And it's our job to figure that out, right? They won't.
And it's going to be your job to figure out when that happens. And it is a big deal if you have, if you have time this way, right? And you find some solution to a differential equation, right? So suppose you have some differential equation, and you find a solution to it. If there is some kind of problem here at, I'm going to call this T naught. And so if there's a problem, actually I'm not going to call it T naught, that's a terrible idea. I'm going to call it T hat.
It's vectored out.
So other hat. So you have some special T where there's problems, right? Examples of problems would be something like y prime's 1 over t.
Yeah, if t hat 0.
You can see there's an obvious problem when t hat 0. Okay, if you have something like this, some category of issue like this, and then you go ahead and tune, right, meaning you use your initial conditions over here to get a solution to that differential equation, it probably looks something like this. So you solve your differential equation using initial conditions from that side. What do you know about what goes on over here?
Nothing.
Yeah, absolutely freaking nothing. You see that?
You don't know anything about negative t?
So
Or to the left of
the interval of validity is going to tell you if you use initial conditions from the other side, right? If you use initial conditions from some interval, right? There's going to be an interval of validity. It's possible that that interval is not very big. If you try to go outside of it and make predictions, it ain't going to work.
Isn't that kind of what you were saying about the bacteria in the pond, right? Once it fills up the pond, it's basically...
Yeah, exactly. Right. So if you're growing bacteria in the pond and you assume it's undergoing exponential growth, there is an upper limit to what the pond can hold. Right? There's even an upper limit to what the universe can hold, right? Like there's a finite number of particles in the universe. If you assume each of them is a bacteria unto itself, which is not reasonable, right? You're still going to run out of issues. And what's going on there is that there's some kind, or run out of space for bacteria. What's going on there is there's some kind of a hard limit on your differential equation, and you cannot make predictions on the other side of it. You guys see that? Determining the interval of validity is a little bit tricky and takes a couple of forms. One is the mathematical model itself. Like in this case, it's clear that I have problems at 0. The other is a more physical thing, right? Like the pond, my differential equation didn't take into account at all the size of the pond, right? But there's a physical constraint. So sometimes the interval of validity is a thing about mathematics, right? It's a thing in the model about about the way you constructed the function. And sometimes it's but I should maybe keep the bacteria in the pond. You guys see that? So sometimes it's mathematical, sometimes it's reality based.
So could you just not model the physical with like a 3D equation and then subject that to one thing or the other?
So that validity thing is going to be a...
Then you just can't worry about the rest of it.
Yeah, sometimes you're just going to say, and my differential equation shuts off when time equals whatever. We're going to do that when we do mixing. So one of our like classic problems is going to be this, like you have a tank with stuff in it, right? The other example is you have cells in your body with stuff in them, right? Like Katie's, you have diabetes, right? So the cells in your body have an extremely important piece of information that you care about a lot, which is the amount of glucose? So the amount of glucose in those cells, right? If you add sugar to your bloodstream, that changes the amount of glucose in the cells, right? And you would be really interested in how that changes. And it's way more complicated than the tank problem that we're going to do. Because the tank problem we're going to do is just like, what if you stir some salt into regular water, right? But that's the basis of where the models for how fast does glucose absorption happen and how much insulin should we take varying on time of day and person and all this stuff. Like, there's a whole huge industry of medicine uptake biology. Is cool with that? And those intervals of validity are things like, and once we reach this level, people die. Or, and once we reach this level, the cells burst. Right? And that would correspond to the tank overflowing, or to me using up all of the water in the pond to make bacteria. Right? That would be disgusting.
It'd be like what it was last summer.
Yeah. Does that kind of thing make sense?